This video is for Math 112 for the section 2.4, and this covers the concept known as phase shift, which is going to affect the x-axis. And when I put out the formula sheet for the midterm, you'll see I kind of separate these concepts based on the x and y axes. Okay, just real quickly, if we've got y equals a sine bx plus c plus d, let's see, the amplitude and the vertical shift, amplitude and the vertical shift, d, those affect the y-axis, right? And then the period, which is 2 pi over b, and the phase shift, which will put the new starting point at the point negative c over b, those affect the x-axis. If that doesn't make a whole lot of sense to you right now, that's okay, because we haven't talked about the phase shift yet. But what it does is it pushes things back and forth along the x-axis. The period stretches the curve, whereas the phase shift actually kind of picks it up and moves it. Okay, so let's talk about this a little bit more. So first off, one thing I want to point out is in section 2.4, we're going to talk about the phase shift and really only the phase shift, okay? I put a whole nother section, 2.5, where we put all of these changes together. That's what I was just talking about with those A, B, C, and D things and how they affect the x and y axis. For right now, for section 2.4, we're just going to talk about the phase shift because it's a little bit tricky. So let me go over the two examples that I put in the textbook for section 2.4. Let's see, let me double check the first one. X plus pi. Y equals the sine of x plus pi. Okay, so I'm not going to approach it exactly the same way as I did in the textbook. So what I am going to talk about is the difference between this and the standard sine function y equals the sine of x. Let me draw a quick sketch of that graph right here. 1, negative 1, 0, maximum, 0, minimum, 0. And there's our graph, y equals sine x. Okay, now notice in this scenario the period is 2 pi. And that'll be true for this one as well. Since we're only talking about the phase shift, we're not going to have a value for b that's going to change the period for our graph in section 2.4. Okay? So if the period is 2 pi, each of these jumps between the quadrantal angles is a distance of pi over 2. Okay? And it's these quadrantal angles that produce these critical values. 0, maximum, 0, minimum, and 0. Those all happen on the quadrantal angles. Okay? Now, if we shift this by adding pi to x every time, well, that means when x is 0, we're going to find the sine of pi, which is over here. And then when x is pi over 2, we're going to be finding the sine of pi, 3 pi over 2, which is down here. Okay? So the key here is two things. First off, these critical x values, or quadrantal values. Okay? That's what produces those points that allow us to sketch the graph. Okay? So really, what we want to know is where is our new starting point? Okay? If we want to find the sine of 0, how is this going to be 0? So if we say x plus pi equals 0, that means x would be equal to negative pi. So that's going to be the first point in our graph back here at negative pi. Okay, so that's going to correspond to that point right there, because when x is negative pi, this will be 0. Sine of 0 gives us a value of 0. Now, the next important point, the next critical value along the x-axis is going to be a distance of pi over 2 away. Each of these jumps right here is a distance of pi over 2. And I'll talk more about this when we get into section 2.5, okay? But for right now, each of those jumps is going to be a distance of pi over 2. So, if we want to go negative pi plus pi over 2, that'll be the next point that'll correspond to that maximum value. So if you want to add these together, let's make a common denominator. That's negative 2 pi over 2 plus positive 1 pi over 2 is going to be negative pi over 2. All right, and that's going to be where our maximum value is right there. Then we take our negative pi over 2 and add pi over 2 to it again. Then the next critical value will be 0. Then take that 0, add pi over 2 again. And that's going to be where our minimum value is. Let's see here. Positive pi over 2. Going to be down there at negative 1. And then take that pi over 2, add pi over 2 again. That's going to give us pi. And that'll be 0. And then that'll do it. Those are our 5 critical x values. Okay? So instead of having this, what we've got over here is negative pi over 2, 0, pi over 2, and pi. Notice that the period is still 2 pi. Okay, that hasn't changed. What we've done is we've taken this and we've shifted it back this way, a distance of pi. All right, so there's the first example. That's the sine of x plus pi. All right. Let's see here. I'm trying to think which one to erase. I think I'm going to keep this one and erase that example because this is in the textbook, and I think I'm going to want this one when I do the second example. All right. So let's go ahead and look at that one. Let's see. Example 2. Y equals the sine of x plus pi over 3. Y equals the sine x plus pi over 3. So again, take that expression in the parentheses and set it equal to 0, because that's going to tell us where our new starting point is. And that's going to be negative pi over 3. Okay? All right, so now let's draw our graph, and we'll put negative pi over 3 along the x-axis, and I'll put my value of 0 there. That's where our graph is going to start. Okay, now we need to take negative pi over 3 and add that jump of pi over 2, which is 1/4 of our period, to get the next critical value. Okay? Now, this involves a little bit of adding of fractions. It's not the end of the world. We all have calculators, and you can all use them. Okay? It's a lot faster for me just to do it at the board than it is to do it on the calculator. So I'm going to make a common denominator of 6 here. So this is going to be negative 2 pi over 6 plus 3 pi over 6. That's going to give us positive pi over 6. And that's where our maximum value of positive 1 is going to happen. Let's see, let me label that. Pi over 6. Okay, so now I want to take that pi over 6, add another pi over 2. So that's going to be 1 pi over 6 plus 3 pi over 6. That's 4 pi over 6. I think in the textbook, and I'll talk about this in one sec, 4 pi over 6, which is 2 pi over 3. So let's see here. We'll put that right about here, 2 pi over 3, and that's going to be where it goes back down to 0. Now, I'll continue to do this, but let me just show you something that we can do here. Let's see here. If I do everything as sixths, because I think this is what I'm doing in the textbook here. So we go from minus 2 pi over 6, and we're constantly adding this 3 pi over 6, so that'll be positive 1 pi over 6, plus another 3 is 4 pi over 6, plus another 3 is 7 pi over 6, and then I think I need one more, 10 pi over 6. And then we can reduce them. Negative pi over 3, positive pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. Okay. Let's see here. So we've got the 2 pi over 3, then we need 7 pi over 6, and then 5 pi over 3. If you want to express these as decimals, I'm not going to say anything about it. If you want to call this negative 0.3 repeating times pi, great. If you want to call this negative 0.16 repeating times pi, this is, oh, that's positive, there we go. 0.6 repeating times pi, this is 1.16 repeating times pi, and that 5/3, that's going to be 1.6 repeating times pi. That's just as good. I'm not going to stop you from doing that. There's nothing wrong with it. This is the standard way that these are usually expressed. I think it's helpful to think of them in terms of fractions. But if you want to set them up this way, so long as you've got the bars over the repeating part, that's fine. If you leave out the bars over the repeating part, I'll take some points off. Okay, let's see here. So let's go back to what we were doing here. All right, let's see. We were up to 2 pi over 3. I'm just going to call it 4 pi over 6. And then again, we're adding 3 pi over 6, because that's equivalent to pi over 2. And there's our 7 pi over 6, which doesn't need to be reduced. And then we'll do that, add on the 3 pi over 6 one more time. There's the 10 pi over 6, and that's 5 pi over 3. A little bit messy, but still 5 pi over 3 nonetheless. And there it is. Okay, so there's half our graph. This one gets the minimum value. That one gets 0. And there's our shifted graph for the sign of x plus pi over 3. Okay, so this process right here, a lot of people find this tricky. So what I'm saying is, if you find this tricky, you're not alone. All right? I encourage you to work through it. I encourage you to use your calculator. I encourage you to ask questions if you get stuck. Okay? But if you find yourself having difficulties, don't just shut down. I want to help you work your way through this. Okay, so those are the two examples, and like I said, we're only talking about phase shift in section 2.4. We're not going to talk about those other ones until we get a handle on the phase shift, and then when we go to section 2.5, that's where we'll work to put all of these ideas together. All right, now the exercises for 2.4, they start out with a matching section, so I don't really have any even numbers to do as examples here. I'm just going to leave all of those 8 graphs for you to match up with the 8 graphs from A through H, match up with the 8 problems from 1 through 8. Okay? You can see some of these have phase shifts. Notice that some of them have the vertical shift. Okay? Problems 3 and 4 are vertical shifts, as is problem 7. All right? And that's the difference between where you have the parentheses. So let me show you here. So like problem 1, y equals cosine x minus pi over 4. That's a phase shift. Problem 3, y equals cosine x minus 1, that's a vertical shift. Okay? The parentheses make this a phase shift. Without parentheses, this minus 1 is affecting the y values and not the x values. All right, now let's look at the problems I can do as examples, 10, 12, 14, and 16. They're going to be very similar to those two examples that I just did a few minutes ago. Actually, I think I'm going to draw that little diagram that I had up on the board a few minutes ago, the standard sine curve, because I think it is helpful to have that as reference. There's our standard period of 2 pi, and then each of these sections right here is 1/4 of that period. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay? Put those in there. And then again, I want to remind us, each of those jumps is a distance of pi over 2, and that's 1/4 of the period. Okay, and then again, we'll put here 0, pi over 2 pi, 3 pi over 2, 2 pi. All right, now let's look at problem 10 here. Y equals cosine of x minus pi over 6. Okay, so the first thing I'm going to do here is I'm going to find out where is our new starting point. So we take whatever's in the parentheses and set it equal to 0, because that's where our starting point would normally be. And we want to find the x value that's going to give us that starting point. So add pi over 6 to both sides, and it turns out our new starting point is positive pi over 6. Okay, great. Now, our graph is still going to have those 5 critical values along the x-axis. Now, it goes off infinitely in either direction, but we can get any of those values from what we understand about what's happening in that one section that we are looking at. Okay? So, we're going to take this pi over 6, we're going to add pi over 2 to it, and just like I did in the last one, let's call that 3 pi over 6. So this will be 4 pi over 6. And this actually has some similarities to that last problem that we looked at in terms of where these are going to be falling. Okay? And so now if you want to count 1 pi over 6, 4 pi over 6, 7, 10, 13, because we're adding 3 pi over 6 every time, right? So we're going to have 1 pi over 6, then we're going to have 4 pi over 6, 7 pi over 6, 10 pi over 6, and then 13 pi over 6. So those are the 5 critical values. This one's going to reduce to 2 pi over 3. This one's going to reduce to 5 pi over 3. The rest of them will stay the same. I'll put these in here. Okay. And where these are coming from again is this process right here. So we can reduce this to put it into our answer, but I'll keep it as 4 pi over 6 to get the next value, which is 7 pi over 6, and then add on that pi over 2 again. There's our 10 pi over 6, which we reduce to put in the answer, but we'll keep it as 10 pi over 6 so that when we add on the 3 pi over 6 again, we don't have to make a common denominator. So there's where all these are coming from. And now that we've got it set up, oh, this is a cosine function. So we're going to start at the maximum, 0, minimum, 0, maximum. And there's number 10. Let's see here. I don't think I have enough room to do number 12 without erasing this. So I'm going to erase that. And if you want to freeze if you want to stop the video, or if you want to rewind it a little bit and take a look at this, that's fine, but I do have to erase it to do. Now problem 12 is actually the same as that second example that I just did there, the sine of x plus pi over 3. So I'm going to skip over to problem 14. Alright, so I don't do the same problem twice. So problem 14 is the cosine x plus 3 pi over 4. So y equals the cosine of x plus 3 pi over 4. Alright, so again, take what's in the parentheses and let's find the new starting point, which is going to be negative 3 pi over 4. Okay. Let's see, I think I might need more room than that. Okay. So, this jump is still going to be pi over 2. Okay. So, if we take negative 3 pi over 4 and we add pi over 2 to it, we want a common denominator, 2 pi over 4. Okay, so this will be negative pi over 4. Alright, so now if we keep doing that, if we keep adding 2 pi over 4 to this, to negative 1 pi over 4, that'll give us positive 1 pi over 4, and then positive 3 pi over 4, 2, 3, 4, and then positive 5 pi over 4, because every time we're adding on this 2 pi over 4. So these are jumping negative 3 to negative 1 to positive 1, 3, 5. If we went past, we would go 7, 9, 11, and so on. But for right now, with this cosine function, we're going to have a maximum, 0, minimum, 0, and the maximum over here. And so our graph will look something like that. Okay? So I'll write down these critical x values, and then I'll go back and calculate them over here. So again, we're adding pi over 2, which is 2 pi over 4, which is helpful to have that common denominator. So there's our positive 1 pi over 4. Add on 2 pi over 4 again. There's positive 3 pi over 4. And then the last one here, add 2 pi over 4 again. And there's 5 pi over 4. And that's the end of the period. Again, notice that this period is it's still a total distance of 2 pi. It's just it's been offset because of this x plus 3 pi over 4. All right. Got one more example to do, problem number 16. Let's go ahead and take a look at that one. Okay. All right, 16. Y equals the sine x minus 2 pi over 3. So, same scenario. And this process will get a little bit more tricky when we get into section 2.5. Right now, it's pretty straightforward. You can look at it and be like, our new starting point is positive 2 pi over 3. That's fine. Okay? This will get trickier when we introduce a coefficient in front of the x. Alright, so I'm just letting you know that if you're planning on skipping this, that's fine by me, but it will get more complicated. Alright, so our new starting point is x equals positive 2 pi over 3. So we'll put that, about here. 2 pi over 3. Okay. Now, again, this jump right here is again going to be 1/4 of the period. Since our period is 2 pi, that jump will be pi over 2. I'm going to need a common denominator here, which is going to be 6's. So I'm going to take that 2 pi over 3, add the pi over 2, and then make them both over 6. 4 pi over 6 plus 3 pi over 6 is 7 pi over 6. So we're going to have 4 pi over 6, 7 pi over 6, 10 pi over 6, 13 pi over 6, and then one more, 16 pi over 6. So once you get the denominators squared away, you get a common denominator, then notice you can just kind of do this, just keep adding to the numerator. You're adding this 3 pi over 6 every time, so you go 4, 7, 10, 13, 16, 19, 22, and so on, okay? Makes it a little bit easier, but again, it kind of leaves out the work that's happening over here, okay? So let's see here. I'll go ahead and do that work. 7 pi over 6 plus pi over 2, oops, equals 10 pi over 6. And then add on another pi over 2. There's our 13 pi over 6. And then one more, 3 pi over 6. And there's our 16 pi over 6. So the ones that have common factors need to be reduced. This one will stay 7 pi over 6. That one's 5 pi over 3, 13 pi over 6, and then 8 pi over 3. So there's our 5 quadrantal angles, right? Those correspond, this is a sine function, so those correspond to the 0, maximum, 0, minimum, and back to 0. And there's a sketch of our graph. Okay, so that's section 2.4. That is how the phase shift works. All right, like I said, when we get to section 2.5, we're going to put this all together and we're going to look at how these things interact with each other, and that will get a little bit more complicated. So I encourage you to get a pretty good handle on how this is working before we move into section 2.5. And as always, if you have questions about this, please let me know. Thanks.